So, of course, congratulations to our 2024 Latinx Green Chem poster winners. We will be hearing about the winners' research today. So, in first place, we have Karen. Karen will be talking about the synthesis, characterization, and UV degradation of polyurethane foams obtained from used vegetable oil. In second place, we have Adriana, who unfortunately couldn't join us today, but hopefully we'll be able to hear about her research another time. And then in third place, we have Vinicius, who will be presenting his work on low-cost and benign Syngonium-derived biochar as a catalyst in furfural conversion.
Amazing. Yes, congratulations to all the winners. So we're going to start off with Vinicius Madriaga, who is a PhD student in chemistry at UFF in Rio de Janeiro. He also has a bachelor's and master's degree from the same university. He is a part of the Biomass and Catalysis Group, supervised by Professor Thiago Lima, which allowed him to engage in research on biomass composition, green synthesis of catalysts, and heterogeneous catalysis applied to biomass valorization. In his studies, the interest is to understand how different biomasses can be valorized, not only as a feedstock, but also as catalyst production. These studies include different types of biomass, such as sewage, sludge, Syngonium plant, and other local biomass to produce and convert a furfural to value-added products. So join me in welcoming Vinicius.
Okay. As you might be aware of, some of the utilization of the depleting sources, such as oil, might be related to some environmental issues like global warming, climate change, and so on. And as scientists, we're looking for how to reduce the oil demand, uh, especially because oil is a very fortunate source to produce fine chemicals, which are substances that we use in our everyday life. So we also can produce
Sorry,
these
Vinicius,
chemical.
we can't see your
Okay,
slide. We see like your presentation mode, but the slide is still on the title slide. Or okay, yeah, there
Perfect.
it is.
Thank you.
thank you very much. Uh, so continuing what I was saying, the biomass is a great renewable source to complement the demand for oil derivatives. And from biomass, we can produce several kinds of molecules which are relevant to the industry overall. And here are some examples. We have some platform molecules, which are the molecules that we can obtain from biomass. And I would like to highlight here the furfural molecule, which is a platform which we can obtain several kinds of compounds that are applicable in several sectors of industry, like pharmaceutical industry, fuel industry, and engineering, and many kinds of appliances. So, what I'm interested in furfural conversion is to produce sustainable aviation fuel. That's what my PhD is about. An aviation fuel, it's a mixture of several kinds of hydrocarbons that has some desired properties to these applies. And we can produce the SAFs, now the sustainable aviation fuel, from renewable sources like biomass. So here we have the pathway to achieve that. We have the first step, which we call pretreatment, that we take the raw biomass and convert it into biomass sugars. Then we dehydrate these sugars and then we perform a dehydration reaction in these sugars to obtain furfural. And In the third step, we perform a condensation reaction in furfural, which is our desired step here to this work. And we increase the carbon chain of furfural and to perform a Lisa AGO reaction to remove the oxygen and the insaturations in the molecule. But what we're going to take a step further in this. We're not going to use only the biomass as a renewable source, but we want to produce renewable catalysts as well. And can we produce this catalyst is the question, the main question here. And the answer is yes. We have here biochars as an example of a renewable catalyst. A biochar is a material that we obtain from biomass through the pyrolysis procedure. And after we do this thermal pyrolysis, we obtain a material which is comprised by inorganic compounds, and also we have an organic structure. And we can use this material to perform the catalysis in this pathway, reaction pathway that I showed before. So when we perform the pyrolysis, the metal oxides still remain in the structure, and we can use these metal oxides as activity sites for catalysis. So here, we choose the Syngonium biomass, which is a very common biomass here in Brazil. And we perform the pyrolysis at 350 degrees to produce the Syngonium biochar. And we're going to apply the biochar to furfural aldol condensation reaction, as we see here. And this step in particular is important to increase the carbon chain, which is necessary to apply as soft in the last step. So, as I said, the biochars have two different parts. We have the organic fraction, and we also have the ashes, which it's the name to the inorganic compounds mixture. We characterize both of them, and we can see here that the organic fraction is comprised by a polycondensation rings in the organic structure of carbon, and it has it has a higher carbon content in this fraction in particular. But we also have a higher content of ashes. The major part of this material are ashes, and we need to study what the ashes are, what these ashes are. So we have here some of characterization of the ashes in particular, and we see that the ashes are most comprised by calcium oxides and carbonates, which are basic substances, basic compounds. And this is a very important thing because we are using these basic compounds as catalytic sites to the reaction of furfural condensation reaction in this case. So it's vital that we have some basic compounds in the biochar structure. And this biomass in particular presents this characteristic. So here we have some surface properties. As we see here in the microscopy, we see the wrinkled layer, carbon layer, and these little fragments that I highlighted here, which are the calcium compounds, the calcium fragments deposited on the structure, the carbon structure. Here are some results we have here, and we obtained this molecule, this first molecule, which we call FAC, and this FAC, FAC is an important product for this reaction, and we achieved nearly 70% of furfural conversion. We have the best condition here in the 105 degrees. The catalyst loading, the best catalyst loading was 150 milligrams, and the solvent, which is acetone, in 3.75 milliliters. So, to conclude, we have here the reuse assay. We performed this reaction several times to the same catalyst, and we observed here a dramatic reduction of furfural conversion. And we have two reasons for that. First is the co-deposition. We have organic matter depositing on the surface of the catalyst, which blocks the access of furfural molecules to the catalyst, and also the calcium lixiviation to the reaction medium, which can also reduce the furfural conversion. This is another work that we're studying here in our research group, which is use this Syngonium biochar and perform a dry impregnation of nickel in this material to obtain a catalyst, a Lewis acid type catalyst to promote the furfural reduction. We also obtained 11% of furfural conversion for this reaction, but there are a lot of studies going on to this catalyst, and we might have some future news. In the future, we're gonna have more details about this work. So the Syngonium biochar was successfully applied as a catalyst for furfural conversion, and we are producing renewable catalysts here from renewable sources, not only using the biomass as a source of fuel, but also a source of catalysts. And the contribution to self-obtention represents both an environmental and economic advance to society. I would like to thank all the collaborators and also the organizers of the event for the invitation, and thank you very much.